Hi everyone, you are welcome back to another interesting question. We are asked to determine the size of angle PSR, that is this here. We have it divided into two angles of size R and 2R. Here we observe two right angles. The length of this side is given to be B. This here is A, and this is square root of A squared plus 9 meters squared. That of this is 12 meters. So how can we solve this? How can we calculate the size of angle PSR? It's very simple. Its size is a summation of this R and this 2R. So angle PSR equal to R plus 2R, which is 3R. We need the value of R. Start from this right triangle. We have its sides to be of length A, B, and square root of A squared plus 9 meters squared. We can use the Pythagorean theorem on it. The Pythagorean theorem states that the square of the length of the hypotenuse of a right angle triangle is equal to sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. So by Pythagoras, square root of A squared plus 9 meters squared all squared equal to B squared plus A squared. Here, square root cancels square. This A squared eliminates this A squared. So 9 meters squared equal to B squared. That is B squared equal to 9 meters squared. Take the square root of both sides of the equation. Here, square root of B squared is B, while here, square root of 9 meters squared is 3 meters. So B equal to 3 meters. That is, the length of this side is 3 meters. Come to this triangle PQS. It is also a right angle triangle, and we have the length of this side to be 12 meters. Here, the angle has its size to be 2R. From the vertex, we draw an angle bisector of the triangle. Call this point A. Since it bisects this angle, and the size of the angle is 2R, this and this each are going to be half 2R, which is R. Now come here. From this vertex, Q, draw a straight line perpendicular to this angle bisector down to line PS. Let this be point B. We look at this triangle BQS. This line bisects this angle of it. Therefore, it is an angle bisector of the triangle. We see it is perpendicular to this side. The only two types of triangle which has an angle bisector perpendicular to the opposite sides are the equilateral triangle and the isosceles triangle. It doesn't matter though which one it is. In both equilateral triangle and the isosceles triangle, such angle bisector bisects the side. Therefore, this side is bisected. That is, this segment and this are congruent. We let them be x in length each. Now let's call this point C. We look at this quadrilateral. This angle and this are right angles. That is, they are congruent. And we see they are opposite to each other. It's fair to say we have a pair of opposite equal angles. We see this line QS is a diagonal of the quadrilateral, and it bisects this angle. This is a property of a kite. It is also common in a square-shaped quadrilateral, but this obviously is not a square. So it is a kite. Therefore, this side and this are congruent, and this are equal. So since this is 3 meters, this must also be 3 meters. Therefore, x equal to 3 meters. And since this is A, this must also be A. Come here, replace x with 3 meters. We look at this triangle. It is a right angle triangle, and we have this angle to be R. Based on the rule that the summation of angles in a triangle is 180 degrees, this must be 180 degrees minus 90 degrees minus R. 180 minus 90 is 90, so it is 90 degrees minus R. Now back to this triangle PQS. From this vertex here, we draw out a median. It will bisect this side. So since the length of this side is 12 meters, this segment and this each are going to be half 12 meters, which is 6 meters. We see the triangle is a right angle triangle, and this median is drawn from the vertex of the right angle. We know the median of a right angle triangle, if drawn from the vertex of the right angle, is half the length of the hypotenuse. This side is the hypotenuse, and this is half its length. Therefore, the length of this side must also be 6 meters. Now look at this triangle. This side is 6 meters in length. The length of this side is 3 meters plus 3 meters, which is also 6 meters. That makes the triangle an isosceles triangle. The based angles of an isosceles triangle are equal, which are this and this. So since this is 90 degrees minus R, this must also be 90 degrees minus R. Look at this triangle. Two of its sides are also equal in length. That makes it an isosceles triangle. So the based angles, which are this and this, are equal. Since this is 2R, this must also be 2R. Now come here, we see this angle is an exterior angle of this triangle, and we know the exterior angle of a triangle is equal to the summation of the two opposite interior angles, which are this and this. So therefore, it's 2R plus R, which is 4R. Therefore, 90 degrees minus R equal to 4R. Take negative R to the right hand side of the equation. 4R plus R is 5R. Divide both sides of the equation by 5. Here 5 cancels 5, while here 90 degrees over 5 is 18 degrees. So R equal to 18 degrees. Substitute it here. 3 times 18 degrees is 54 degrees. So angle PSR equal to 54 degrees. Thank you for watching. Please like, share and subscribe, and also turn on notifications. Thank you.